of the club members. So I had made the suggestion that what would be good would be something that's at a level that everyone could enjoy. You would have something for people who are a little more casual, who are not into astrophysics, don't want to travel to star parties at night in Pound Ridge. Some of our club members have telescopes, some don't, but we all like looking at the night sky. So so I had made the suggestion that a presentation on what are the things to look at in the sky, primarily naked eye, but also with telescopes and binoculars. How do you find them? Where in the sky are they? Are they in the east, the south? Are they up high, low down by the horizon? And what can you see there? And also information about the constellations. And so Larry asked me to put together an outline, a detailed outline, which I did. And then Larry took it from there and created the slides with star maps, photographs, other pictures and stuff, and really made it come together.
Call from Karen Bodum.
Hello.
Hey, Everett, if you could mute, please. And I think if everybody could just check and mute their lines, please.
On my way.
Everett, does that mean we're going to lose you?
Only for a moment.
Okay. So the
But
presentation.
I'm going for mute on a new computer.
There we go.
Okay, thank you. Okay, so we're going to describe the constellations that can be seen in the early spring, because that's where we are now. And knowing what direction to look is not as simple as it sounds because the Earth rotates. So it appears as though the stars are slowly moving across the sky. So which direction you look depends both on what time of night it is, but also on what month you're looking. And that's because the Earth is also revolving around the sun. So as it goes around, the nighttime is facing a different part of the sky, different constellations, different stars. We're going to see what the constellations look like, what the stars look like with the naked eye, and also with lines drawn showing between the stars that help visualize the pattern. Also show a drawing that shows the person, animal, or object that the outline represents. We'll discuss the myths behind the constellations and talk about what you can see with binoculars or a telescope. And one of the things that helps find the constellations and things you're looking for is to know about the brightest stars in the sky and which constellations they're in. And that'll help pinpoint you to the right place to go looking. So constellations are patterns of stars that people a long time ago thought that they looked like a person, maybe they looked like an animal, maybe they looked like some kind of object. And every culture in the world has created constellations and myths about those constellations. The Babylonians identified things a couple of thousand years, about 3,000 years ago or more. And by the time of the ancient Greeks, a few hundred years BC, they had described 48 constellations. Southern constellations, which the Greeks couldn't see, were added later, several hundred years ago, by the explorers who first went to the southern areas, and later some of them by scientists who took astronomers who went there. And today, starting in 1930, the International Astronomical Union has defined 88 constellations with very specific borders, and those are now used uniformly throughout the world by the astronomical community. The first and earliest map of the constellations was the Farnese Atlas, and this is a picture of a Roman copy of the original Greek one, and it can be found in Naples. And as you can see from the size of it, and since it's made of marble, you can imagine it's quite heavy, and it's probably not what you would want to lug out to the field with your telescope to use. Before we look at the types of sky charts there are, just want to talk a little bit about stargazing. Stars have been given names, many of them. So the brightest stars have names which often came from Arabic astronomers in the Middle Ages. And some examples of star names are Betelgeuse and Polaris. But, if all we had was the name and nothing else, it would be very hard to memorize all of the naked eye stars. Their names, where in the sky they're located. If all you had was the name of it, I mean, you would have a couple of thousand names to memorize. But from an astronomy point of view, by dividing the sky into constellations, a naming system was devised in which the brightest star of each constellation was usually called the alpha star, alpha being the first letter of the Greek alphabet. The second brightest would be the beta star. So, for example, Alpha Centauri is a multiple star system in the constellation Centaurus, and it's famous for being the closest star system to the Earth. Alpha Orionis is Rigel, and Beta Orionis is Betelgeuse, and those are two stars in the constellation Orion. So now, with this convention, we have a lot less to memorize, and you can tell by the name where in the sky to look for that star. So sky charts that are a little bit smaller than the Farnese Atlas can be found in a lot of sources. There are charts in observing books and magazines. Sky and Telescope and Astronomy magazine have a sky chart or map every month, which shows the view at a particular time of night on sometime during that month. It may be the 15th of the month. It may say have different times for the 1st of the month, the 30th of the month. Standalone sky charts like Uranometria 2000 and others like that are also available. And then there's an object called the planisphere, which you can see on there, which is a plastic disc that has a couple of concentric circles. So the inner circle has the time of day, and you move it around to match a particular month and day of the month. And that'll show you what the sky looks like, the nighttime sky, at that particular time. So it can be used throughout the year. You don't need a different piece of paper for every month. And the way it works is that center section shows the stars that are visible that night. It shows where the North Star is, and we'll talk about that in a little while. And you can rotate it to see how it changes during the course of the night, or you can change the point to a different day. So that's a planisphere. And of course, in the last couple of decades, we have planetarium software to run on your computer or your smartphone that will show all the same things, but you can pick exactly what time of day, what day of the year you are, what your latitude is, and it'll give you a customized map for that particular time. And two of the most popular planetarium programs these days are Carte du Ciel and Stellarium. And all of these tell you in which direction to look for the object you're looking for. And the star map shows you the stars and also the constellation lines to help you visualize that pattern. Now, the Earth rotates around its axis, and that's the axis in which it's spinning. And it's an imaginary line that goes from the North Pole to the South Pole. Since the Earth is rotating, when you look at the sky, it makes it appear that the stars are slowly moving across the sky. The Earth's axis is tilted by 23 degrees in relation to the plane of the solar system. And the plane of the solar system is called the ecliptic. And that's the path that the Earth takes going around the sun. So because the Earth is going around it, it looks like the stars and constellations are also revolving through the course of the year. And again, they also seem to be rotating around the North Star. So this is an animation showing the movement of the stars during one night. So each frame that it advances is 30 minutes. And we can see
Click it again, Joe.
no, I don't want it to move yet.
Oh, okay.
Actually, I'm going to back up for a second and then go forward. So starting at the beginning, and we can see I was a little bit slow. So in the early spring, Taurus the bull is low in the western sky. And this bright star here is Aldebaran rather, and these are the horns of the bull. Nearby, a little bit further east, is Orion, the hunter, that has Betelgeuse and Rigel. And again, we'll talk more about that later. And it also is low in the west. So the first things you're going to want to look at if you go out now or in the next few weeks are those two constellations while they're still up. If you wait till later in the night, they'll have already sunk in the western horizon. Polaris is up here. It's pretty far in the north. Now, the middle of this map is straight overhead. And you see that the North Star is not straight overhead, and that's because of the Earth's tilt, 23 degrees. And all the constellations and the stars will appear to rotate around Polaris. So after Orion, we have Gemini, and over here we have Leo the lion, Boades the herdsman, and as we go through the night, we can see it all rotating, which also shows that during the course of the night, if you stay up late enough, the constellations will set in the west, and new ones will be turning up in the east and coming across the sky. And some of these are considered summer constellations or later, depending on how late you stay up. And a lot of amateur astronomers do stay up late into the night to look at things. I don't. I prefer going to bed at a reasonable time, like 1 in the morning. And for some people, that's not reasonable either. But don't worry, if you want to see some of the others, you just have to wait a couple of months. This next diagram shows how things rotate over the course of the year. So each frame is 7 days. And you may notice that it's the same constellations in the same relative positions. We've already gone part of the way. So at this point, Gemini is already over here, and the summer constellations are starting to appear. Oh, sorry. I will start over. So now we've got the summer constellations in the middle. Hercules is pretty high in the north. Still looking south at this point, but it's pretty high up in the sky towards straight overhead, the zenith. But we've got some new things. Here's Virgo, the Virgin. And coming up, we have, by the summer, we have the summer triangle. We have Deneb in Cygnus, it's a swan. Vega in lyre, the musical instrument lyre. And we have Altair in Aquila, the eagle. Up here, we've circled around a good bit, and there's the Great Bear. But if you notice, Polaris, the North Star, is still in the exact same position. And we've reached the four constellations. There we have Pegasus, the flying horse, Pisces, the fish, and so on. And we've actually circled around a good part of the year. If you notice, Taurus is rising in the east. And the winter constellations have come and are passing through. There goes Orion. And we've come around for a full year. Now, how much you can see, how many stars, and how easy it is to see the patterns will depend on the amount of light pollution. And this chart shows a scale called the Bortle scale, which demonstrates the difference of what you can see between a really, really dark sky site, rural, suburban, like where we are, which covers all of these, especially these two, 6 and 7. The city and New York City, you're only going to see a few stars in Manhattan. This animation shows, and again, I'm going to back up and come forward again. This chart shows the effect of light pollution on visibility. And this picture on the right shows that the New York area is extremely bright, including Yonkers, and down in the corridor heading towards Philadelphia. The further out you get, for the most part, the skies get darker. This shows the stars that you could see naked eye in a dark site. It also has the constellation lines drawn around it to help you visualize. Here's Orion, Betelgeuse, Rigel, Orion's belt and his sword, Taurus. But no matter how dark the sky is, no matter where you go and no light at all, completely dark, you will not see the constellation lines. So therefore, you have a little more work to visualize the constellation, but you can still see here, Orion is very easy to pick out, as is this part of Taurus. Now we're probably in a medium dark site, maybe Pound Ridge. You could see something like this. In Middle Westchester, Lower Westchester, you can probably see these stars. You can see the Pleiades star cluster, the Hyades star cluster, which is part of Taurus, and you can still pick out a number of stars in Orion. And as you get down closer to the city, you can just see the brighter stars, and eventually not even that much. This is star chart of the western horizon on April 1st at 9 p.m. And the way all these star charts work, the ones in the magazine, the planisphere, is by default, right side up, it shows the view when you're facing south. If you want to see what things look like to the north, you turn the image around 180 degrees, and that'll show you what it looks like facing north. If you want to look to the east and want to see what the sky looks like, you turn that map so that the east is closest to you. And that'll give you the view when you're facing that direction. Now, you can, of course, look straight up, and if you crane your neck and lean back, you might be able to see the zenith and maybe even past it. But again, it's a lot easier if you turn around and face north to look at those. But of course, it changes the viewpoint of what the constellations look like. So again, Taurus is heading to the south. Orion is a little bit to the east of Taurus and also heading down to the western horizon. And here is a drawing in the star maps and atlases that were created in the 1700s. The cartographers drew pictures of the constellations. So it not only has the stars like Aldebaran in the Hyades cluster, and here's Betelgeuse and Rigel, but it also has a picture of the object that the constellation represents. So it's quite pretty. I mean, they can be really beautiful. Makes it a little bit harder to see the stars themselves, but I mean, they're beautiful to look at. Now, there are patterns of stars that are not constellations. And sometimes if it forms a recognized pattern that looks like something, they're often called asterisms. The word aster being the Latin word for star. And the Hyades is very large in the sky as clusters go, and that's because it's a lot closer to the Earth than many other open star clusters. And being closer, there seems to be more spread among the stars. And the bright star is Aldebaran. The Pleiades is another star cluster you can see naked eye. And it's actually probably the most beautiful cluster to look at with binoculars. And the reason that binoculars are the best thing to look at the Pleiades is not only can you see more stars, and it's bigger so you can see it better, but it's small enough to fit in the field of view of a pair of binoculars. In a telescope, unless you have a wide field eyepiece and a wide field telescope, what's called a rich field telescope, the Pleiades probably won't fit all at once. The telescope will show you even more stars, but to see the whole thing, binoculars are perfect. The Pleiades represent, in the myths, 7 sisters. And there are myths about it, which we'll talk about in a little while, but also the name of this cluster in Japan is Subaru, which is the Japanese word for the Pleiades. And if you happen to have a Subaru car, or have seen some around, you'll notice that Subaru's logo is a little cluster of stars. And this is a photograph through a telescope of the Pleiades. So as you can see a lot more stars, and you can also see some gas and dust clouds that are passing through there and are they're blue in color because they're reflection nebula. They're reflecting blue sunlight, starlight. Now, the Pleiades are also well known as a test of eyesight. Traditionally, and the reason there is called, 7 of them, was that in a dark sky, you could see 7 of them naked eye without optical aid. But in actuality, in a dark sky, and probably in ancient times, people with good eyesight could see more than 7. People have seen 8, 9, maybe even 10 of them. And if you can see, there's 1, 2, 3, 4, 5, 6 that are particularly bright. But some people can see this one, or maybe this one and this one. With more light pollution, and as your eyes get older and your vision not as good, you're probably seeing even less than 7, or even less than 6. But it's a good star test to see how good your sky is, how dark things are. And when you look through binoculars, you see many, many more stars, all of these. And through a telescope, you can see a lot of faint ones too. Orion is more of a winter constellation, but it is still visible for a little while now. And Orion was a hunter, and he's got his shoulder is Betelgeuse. His lower ankle and knee, depending on the picture, is Rigel. And those are 2 of the 15 brightest stars in the northern skies. He's got a belt, and he has a sword that comes down. And he's got a shield, and he's raising a club. And he was a hunter. And Orion was the son of Poseidon, who's the god of the sea. Now, one thing to distinguish in the names of the gods is that the Greeks had a set of gods. The king of the gods was Zeus. His brother Poseidon was the god of the sea. Hades was the god of the underworld. The Romans had the exact same gods, but they had their own names for them. Jupiter was the king of the gods. Neptune was the god of the sea. And Pluto was the god of the underworld. And as you can tell, the planets were named after the Roman gods. So Orion's father was Poseidon, and his mother was Euryale, who was one of the Gorgon sisters. The Gorgons had snakes for hair and could turn people to stone if the person looked at them. And the most famous Gorgon was Medusa, who you've probably all heard of, and she was slain by Perseus. But Perseus is a different constellation and a different myth, so we'll leave that one there. Orion was very boastful, and he boasted that he could slay any creature on Earth. And Gaia, who the Gaia satellite is named after, got very angry at this and sent a scorpion after him. And Orion and the scorpion had a fierce battle, and both of them died in the battle. And Zeus immortalized them by putting them both, Orion and Scorpius, into the night sky. But he put them in opposite sides of the sky, one in winter and one in the sun, so that they couldn't get at each other anymore. Before that happened, before Orion's demise, he had also at one point decided to pursue the Pleiades. The 7 daughters, they were the 7 daughters of the Titan Atlas, who you may remember as being the person who held up the Earth for a long time. And that's why atlases are named Atlas. They were named after the Titan who held up the Earth. And both terrestrial atlases, road maps, street maps, and celestial atlases are called atlases. So Orion chased the Pleiades across the heavens, and seeking protection from the gods, they were transformed into doves and placed into the night sky as the beautiful cluster we just looked at. When you look at Orion in binoculars, and definitely in a telescope, you'll notice that the middle star of the belt, not the belt of the sword, is fuzzy. And that's because it's not a star at all. It's actually a large emission nebula, which is a star factory. It's a large cloud of gas and dust in which new stars are being formed. And it has two names. It's called the Orion Nebula, and it's also called M42. M standing for Messier, who compiled the catalog of a little over 100 objects that were fuzzy. And he created this catalog so people wouldn't mistake them for being comets. But it contains many different kinds of nebula, from galaxies to star clusters to emission nebula. And as you can see, it's fuzzy there, and this is what the telescope view would look like. In almost any size telescope, it will look at least like this and more detailed in a larger scope. And those are the names of the four brightest stars in Orion. And you notice that Betelgeuse is a red giant star, and Rigel happens to be a blue giant star. And to the east of Orion and a little bit further up in the sky is Gemini the Twins. And this is one of those constellations that really look like what they represent. The two bright stars are Pollux and Castor. You can see the stars, even without the lines, you can see stars forming lines down that represent the body and the legs, and the stars going across, forming the arms. And of course, this is from another star atlas from Bayer called Uranometria. And again, a picture of the twins. So this constellation, I said the brightest stars are Pollux and Castor. And this constellation's an exception to the naming rule. Of course, Pollux is the brighter of the two, but for some reason, Castor was given the Alpha designation. So Alpha Gemini and Beta Gemini is Pollux. And these are twins by different fathers, according to the myths. Castor's father was the king of Sparta, and Pollux's father was Zeus, the king of the gods. So therefore, Pollux was an immortal, but Castor was mortal and could be killed. Their mother was Leda, the queen of Sparta, and Zeus disguised himself as a swan and seduced her. And there's a good chance you've seen paintings of Leda and the swan, because there are many, many paintings of this legend. If you go to Google Images and look for Leda and the Swan, you're going to see a number of different paintings by many different famous artists that are in different museums around the world. And Castor and Pollux were renowned for their bravery and combat skills, but in one battle, Castor was killed. Pollux, grief-stricken, begged Zeus to reunite them. So he did, as the stars of the constellation Gemini. Now, Gemini, which meaning twins, has been used as the name in various other things in space and astronomy. For example, the US space program has had several different programs. Right now, it's primarily the space station, and before that was the space shuttle. But we all know that Apollo was the set of missions that took us to the moon. And Apollo had 3 astronauts in it. But the first manned space mission program of the US was called Mercury. And it had 1 astronaut. The very first American astronaut was Alan Shepard, who flew a suborbital mission. And the third astronaut was John Glenn, who flew the first United States mission to orbit the Earth. The second program after Mercury was called Gemini because it had two astronauts on each mission. And some of its prime accomplishments, it included the first American spacewalk and the first rendezvous of two craft and the docking of the two ships. Gemini is also the name of two of the very largest observatories on Earth, and they're called Gemini North and Gemini South. And as the name implies, one's in the northern hemisphere and one's in the southern hemisphere. Within Gemini, there are a couple of objects for telescopes. Messier 35, along with is an open star cluster, along with NGC 2158, which is much further away and therefore looks smaller and more compact. And an open star cluster is a set of stars that were born or created from a single cloud of gas and dust. And these stars were all born at about the same period of time from the same cloud and are loosely coupled gravitationally, but very loosely. And the size of these clusters can range from a few dozen stars all the way up to about 1,000. Messier 35 has about 500 stars. The picture on the right is a binary star, Castor A and B. Castor itself looks like a single star to us naked eye, but when you look at it in a telescope, you can see that it's really two suns. And a binary is one in which the two suns are orbiting around the common center of gravity. There can also be triple stars, quadruple stars that are all tightly bound gravitationally. There are also double stars that are not binaries. They're actually called optical doubles, in which they're totally unrelated at different distances, but they just happen to be lined up in the sky in the same direction. Auriga is a constellation, and Capella is one of the brightest stars in the northern sky. And here's the outline of the constellation. Auriga was a charioteer, and there have been a number of variations on its myth, each variation identifying different people that it represents. And here's a picture from one of the old atlases, and the star chart, which shows Auriga and the other main stars. And it also shows Auriga is best known to amateur astronomers for its trio of star clusters, which can be seen as a faint smudge with binoculars in dark skies, but with a telescope, they're beautiful clusters, open clusters of stars. And they're all easy to find with a telescope once you know that they're in Auriga and you know where in the sky to look for it. To the left of Gemini, we have Cancer, which is a crab. And Cancer, well, Hercules, who we've mentioned briefly, I think we mentioned him, but Hercules was given 12 tasks to do, called the 12 labors of Hercules, which included things like defeating various monsters and large animals, cleaning out a stable full of animal dung. One of the large animals or creatures or monsters that Hercules had to defeat was the Hydra. The Hydra was a monster with many, many heads, and if you cut off one of them trying to kill it, two heads would replace the one. So as you could see, that wasn't going to work very well. But during this battle with Hercules, Cancer the crab came along to help his friend Hydra, and Hercules stepped on Cancer and killed him. Now, Hera, who was the queen of the gods and called Juno by the Romans, she didn't like Hercules because she was married to Zeus, and Hercules' mother was somebody else, a mortal, and not Hera. So she tended not to like Zeus's children that were not hers. So after Hercules killed Cancer, the crab, Hera rewarded the crab by placing it in the heavens. M44 is another open cluster in Cancer, and it's called the beehive cluster. It's also called Prasepe, which means the manger, and it's also known as Messier 45. And it's called the beehive cluster because when you look at it in binoculars, it really looks like a swarm of bees. A really nice object to look at in binoculars and telescopes. Small telescopes work well with that. Next, further to the west, we come to Leo, the lion. And we find that we're going to look at the star chart in a minute. Its brightest star is Regulus, which is again one of the top 15, and it forms what looks like a backwards question mark in the sky. It also looks like a scythe. A scythe is a curved metal blade on a wooden handle, and it's used for chopping down wheat and tall grass. You swing it back and forth, and slice them up. So it's often referred to as the scythe, but to the casual person, it looks like a backwards question mark. And Leo's body comes off to the left. And Regulus is the heart of the lion. The tail is Denebola. And when you see the stars in the pattern, you can really visualize a lion from it. Leo also has two sets of galaxies that are fairly easy to find in telescopes. And so they're relatively bright as galaxies go. And you've got M65 and 66 near each other. And these three, M95, 96, and 105, they can all fit in a single field of view of a wide field eyepiece. Now, Leo is also part of Hercules legend, and Leo represents a real animal, a lion, not a mythological one like Hydra. And the first of Hercules' 12 tasks was to kill the Nemedian lion. The Nemedian lion was attacking a town or a city and the people in it, and it had an impenetrable hide. Weapons were useless against it. So Hercules' job was to kill it. So he strangled it with his bare hands. And then he took the hide for himself as a protective cloak. And many of the paintings and sculptures of Hercules depict him carrying that hide. So Ursa Major is the Great Bear. And part of it is probably the most famous asterism in the sky, called the Big Dipper. In fact, it's even easier to spot and recognize than Orion. And every culture in the world has created constellations and asterisms of this object. In some parts, it represents a wagon. In England, they refer to it as the plow. Again, we call it the dipper, and it looks like a dipper. Here's the ladle, here's the handle. But how it appears in the sky depends on what time of year and night you look at it. This is actually how it looks in the fall to us. It's low it's facing north, but it's low in the sky, and it's facing up. Later on, so here we are on the animation as we're rotating during the course of the year. So first off, right now in the spring, facing north, you would have this part facing you, and you'd be looking this way. And you would see the North Star, and above it, further north, you would see the Big Dipper, but this would be what you would see on the bottom, and this would be on top. So it's the reverse image. And when we get to the summer, it's now over here in the west on its side. In the fall, as I said, it looks like a dipper. It's below, when you're facing north, it's below the North Star and the Little Dipper. And it's close to the horizon, but it's facing upright. And as we come around to the summer, it'll be up high in the east. Well, actually, let's come back to this for a second. So an interesting thing about the Big Dipper is that you can use it to tell time. At night, if you go out at night to look at the stars and you've got a nice clear sky, but you forgot to bring your watch and you forgot to bring your smartphone, you can still tell time. Because if you know what time of year it is, you know, and you go out at 6 o'clock, in the winter when it's dark, or a bit late, or 9 o'clock now in spring, now at 9 o'clock, that's where the Big Dipper is going to be. The day rotation is 24 hours. So 3 hours, 6 hours, there are three of 4 6-hour periods in the day. So every 6 hours, the Big Dipper is going to move 90 degrees in the sky. It'll move to the west, and then to the further south, the other side of the North Star, and then to the east. So in 6 hours, it'll move 90 degrees. In 3 hours, it'll have moved about 45 degrees, and 3 hours from 9 o'clock will be midnight. So if you go out at midnight and you see it over here at this time of year, you would know it's midnight. If you go another 3 hours, sorry, I've got to time my pauses a little bit better. This is 3 a.m. So again, if you're out there for a long time, and over here you looked and it was midnight, and now it's gone a little further, and now it's here, you now know it's 3 a.m. If we travel 6 more hours, where in the sky do you think you'll see it? And that's actually a trick question, because 6 hours later, you're not going to see it at all. Because 6 hours later is going to be 9 o'clock in the morning. It's going to be daytime, and you won't see it. Its position will be up here, but that's it. Another useful thing is it's how do you find Polaris? You know it's due north, but where is that exactly? And you can use these two stars of the Big Dipper, and they're called the pointer stars, and you follow them in a straight line and you come straight to Polaris. And that's any time of the night, any time of the year. Wherever it's positioned, it's rotating around Polaris, and these two stars are always going to point there. And Polaris is part of the constellation Ursa Minor, the Little Bear, and the asterism, the Little Dipper. Now, the Little Dipper stars, except for Polaris, are a little bit fainter than the Big Dipper, so you need reasonably dark skies to see all of them, and they're each like a magnitude apart. So in Middle Westchester, you can see some of them, and in North and Westchester, you could see all of the ones of the Little Dipper. Now, one of the myths concerning Ursa Major and Ursa Minor is the story of Callisto, who was a nymph, which is a young woman who Zeus decided to seduce in disguise, and she gave birth to a son. And some of the myths say it was Hera, and some say it's Artemis. Were so mad at this that they turned Callisto into a bear. Years later, her son had grown up to become a very good hunter, and he came upon this bear and was getting ready to kill it. But Zeus intervened so that he wouldn't kill his mother. And what he did was he turned the son into a bear, and he put both of them in the sky. Now, by the way, we study the myths not just because they're fun to listen to, but they're also informative, because the myths are not just about the sky, it's about these people, and they tell us a lot about the cultures and the history of the people who created them. And again, a lot of movies have been made about the myths, Hercules in particular. So it's an enjoyable pursuit, ancient mythology, whether or not you also look at the myths of the sky. So a few words about some objects that are best seen in telescopes or binoculars. And we'll look a little bit at galaxies, globular clusters. We already looked at open clusters and double stars and planetary nebula. To the east of Leo is an area that has Virgo, pretty close to the southern horizon, and Coma Berenices. And this area, these two clusters, constellations, is often called the realm of the galaxies, because they have many, many galaxies within them, which can be seen with telescopes, especially in darker skies. Now, Virgo being fairly far south, and from where we are, south means New York City and a lot of light pollution. The sky is much brighter there. So you might find the galaxies in Coma Berenices a little bit easier to spot at first, just because it's higher up and a little less light pollution. And Coma Berenices is one of the best constellations to look at in binoculars. And what Coma Berenices means is Berenice's hair, actually the comb of Berenice, but it represents her hair. And in binoculars, or a wide field of view in a telescope, it really does look like a cascade of stars that give the appearance of long flowing hair. And this is the only constellation named after a real historical figure. It was Queen Berenice II of Egypt, and she cut off her hair as an offering to the gods to ensure the safe return from battle of her husband, Ptolemy III. And not only was that a wonderful gesture, but of course the gods then put her hair into the sky. Now, it's often useful to follow from one star pattern to another, or star to another, to find other things. And there's a saying that goes arc to Arcturus. You follow the arc of the Big Dipper's handle to find Arcturus, again, one of the brightest stars in the sky, and that's part of Boades the herdsman. And then you can spike on to Spica, which is in Virgo, another very bright star. So now, with these as pointers, these guide stars, you can easily find your way around this part of the sky. So here are some photos of galaxies taken by members of WAA. And a lot of galaxies are spiral galaxies. They have a beautiful spiral shape. But if we see them face on, we can see that. If we see them edge on, we can't see the spiral, but we can see in a lot of them a dark central dust lane. And we can see the halo, or the galactic bulge, which has a lot of stars a little bit thicker than the disk itself. The other main type of galaxy are elliptical galaxies, which can often be extremely large and bright. M87 in Ursa Major is one of the brightest elliptical galaxies. And here are some others taken by club members. The Whirlpool has its name for obvious reasons, and that's one of the most beautiful ones in long exposure photograph. And again, you're not going to see this with just the eyepiece through the telescope. You will see it in telescopes that, like the C-Star, for example, that actually create long exposures. And if you have a very large telescope in a dark sky, you can see these. Again, not to this much detail. In a smaller telescope, you can see these, certainly from Pound Ridge, Ward Pound Ridge, where we have our star parties, but you'll see them as faint smudges of light. And in darker skies and bigger telescopes, you'll see them as brighter smudges of light. But if you get really dark and really large, then you can start seeing spiral shapes. The next type of object are globular clusters, which are clusters, very tightly coupled clusters of stars, which can have 100,000 stars in the one cluster. And these globular clusters are actually as old as this Milky Way galaxy. And the brightest one in the sky is Omega Centauri, but unfortunately for us, it's in the constellation Centaurus, which is far in the south. The brightest globular cluster in the northern sky is Messier 13, which is in Hercules. And Messier 92 is also in Hercules, but it's a bit smaller and not as spectacular. We talked about double stars. One of the most famous ones is Albireo, which is the second brightest star in Cygnus. And it has a beautiful color contrast in binoculars or in small telescopes, a red star and a blue star. And when you have a binary with color contrast, it's just a gorgeous sight. We talked about what open clusters were, and here are some more, again, with pictures taken by club members. And there are some that are good in big telescopes and some that are beautiful in small telescopes. My favorite is M34, which is in Perseus, which we're not doing tonight, but it just looks just right in a small scope. planetary nebulas have nothing to do with planets. But when they were first discovered, they looked like disks and reminded the astronomers of planets because of that. And that's how they got their name. But they're really old stars that have reached towards the end of their lifetime as a main sequence star. They've shed a lot of their outer layers of gas and dust, and they are now white dwarf stars, which are very hot and compact. A white dwarf star is about the size of the Earth, but hotter than our sun. And the radiation from that white dwarf is lighting up the gas and dust surrounding it. And one of the most famous ones is M27, the Dumbbell Nebula, because the general shape looks a bit like a dumbbell. The easiest planetary nebula to find is the Ring Nebula, which is M57, and that's in the constellation Lyra. And the reason it's so easy to find is because it falls right in the middle of a line connecting two stars that are not that far apart in the sky. So it's very easy to track down. Now, the planets are not, unlike the stars, do not come back to the same spot every year, because the planets also orbit our sun, but at a different rate than the Earth does. So in the course of one Earth year, the outer planets like Mars and Jupiter will travel less than a full circle around the sun. The inner planets like Venus and Mercury travel faster than the Earth. But this year, we have a couple of planets that are up. A few months ago, all 7 planets besides the Earth were up in the sky at the same time. Some of them, like Neptune and Uranus, you needed binoculars or a telescope to see, but the others were lined up across the ecliptic, the plane of the solar system, from west and across to the east. By now, Saturn has already set in the west, but we still have Jupiter in Taurus, and Jupiter is brighter than any star, and the only thing that outshines Jupiter, other than the moon, is the planet Venus. And we have Mars, which is in Gemini. And a couple of months ago, Mars was over here and formed a right angle with Castor and Pollux and Mars, but right now it's lined up in a line. And a few years ago, when they were in this lineup, and I went to look at Gemini, and I looked up and I said, there are triplets. Instead of twins, there are triplets. And that's what it looks like. And this chart shows the path of Mars over the next couple of months. So right now it's lined up with the arms with Castor and Pollux, or his arms. On the 15th, it'll still be lined up, and it's going to move further to Cancer and beyond, and over towards Leo as we get to June. And soon enough, in a couple of months, summer will be coming. And this sky chart shows June 1st at 11 o'clock at night. And we can see now that Leo is moving to the west. Virgo, Coma Berenices, Boades are to the south. And Hercules is in the southeast and pretty high up in the sky. Again, this is the zenith. So Hercules is up high. And when it travels across the sky, it's going to always be fairly high up. And starting to appear is the summer triangle, which has Vega in Lyra, Deneb in Cygnus the Swan, and Altair, which is part of Aquila the Eagle. Vulpecula has M27, the Dumbbell Nebula. So those are some things to look forward to a couple of months from now. And Hercules is the last constellation we'll look at. We've already talked about his myths. And You can spot him high up, and the thing that distinguishes him visually is his body called the keystone, which is a trapezoid, and it's fairly easy to pick out among the stars. And M13, the globular cluster, is easy to find because it's directly on a line between these two stars, the long end of this trapezoid. And the objects in Hercules are M13, M92, the other globular cluster. There's a nice double star down in his foot. And that's it.